Welcome to Mickey Study Circle channel. In this video, we shall see how to create the computer drafting of the orthographic projection of points using the Solid Edge software. So here we have the problem statement. That is, we need to draw the projections of the points on the same XY line, keeping convenient distance between each of the projectors, and also we need to identify the quadrants in which they lie. So we'll take up the first point, which is the point A, and it is located 30 mm above the HP and 30 mm in front of the VP. So before we proceed towards the solution, let us create the XY line, which is the interference of the vertical plane and the horizontal plane. So let me select a line of thickness 0.18 mm and draw the common XY line. So in the IntelliSketch, I can just keep the midpoint off and click OK. So now I can just go to the annotation and select the text option and annotate the reference line as X and Y. So this is the reference line which marks the intersection of the two reference planes, namely the vertical plane and the horizontal plane. So now we'll look at the point A, which is 30 mm above the HP and 35 mm in front of VP. So since the object is above HP and in front of VP, we can understand that the point A is in first quadrant. So now how do we locate this point? So we'll take the line option, select the projection line of thickness 0.13, and since the object is 30 mm above HP, its front view will be recorded 30 mm above the XY line. So this is the vertical trace of the point, followed by the top view of the point, which is 35 mm in front of VP. So with this, we complete drawing the traces of the points. So we can just keep the relationship handles off so that the marks are not seen like this. So now we can just go to the smart dimension and show the dimension. So this is 30 mm and this is 35 mm. So now this particular point is located at the end point of this projection line. So we'll select the point option in the drop down of the line and select the point thickness to be equal to 2.5 mm and click OK. So now we'll simply place a point at the end point of these two projection lines. So now we can go to the annotation option and then annotate the front view of the point A as A prime and then the top view of the point A as small a. So hereby we have created the multiple views of the same point, that is the front view and the top view of the point A. So we can make a note that point A is in first quadrant. Now we'll take up the second point. So since it has to be done on the same XY line, I'll be using the same XY line for drawing all the solutions. So now the point B is 35 mm above the HP and 40 mm behind the VP. So the object is behind the VP and above the HP. So we can understand that the point B is in second quadrant. So how do we locate this point? Select the line option. Ensure that the line thickness is 0.13 mm. So we are going to draw the vertical and the horizontal traces of the line. So 35 mm above HP. So 35 is here. So we are going to record the front view, and the front view is always recorded in the vertical plane. Next, followed by again the line option. So we can just assume that the horizontal plane is rotated in the clockwise direction at an angle of 90 degrees, and thereby it is overlapping on the vertical plane. So which tells that the top view and the front view are on the same traced lines. So this is the 35 mm above HP and 40 mm behind VP. So that will be on the same trace line. So what I can do is I can add extra 5 mm for this line as a continuation. And this is the point where the front view will be marked. So again, let me go for distance between, select the topmost end point and then the base point on the XY line. So this is where I can locate the point. So let me just go to the point option, select the thickness of the point to be equal to 2.5 mm, and then I'll be placing the point here, that is at a distance of 35 mm and also 40 mm. So now we'll go for annotating the point. So let us understand it is 35 mm above HP. So the front view is recorded as B dash, followed by 40 mm behind VP. So the top view is recorded as small b. So this is how I can locate the point B on the same traced line. So I can just enter that the point B is in second quadrant. So we'll take up the next point, that is the point C. So he tells that the point C is 40 mm above the HP. So it is above the horizontal plane and is on the vertical plane. So there is a chance that the point C could either be in the first quadrant or in the second quadrant. So now let us see how to locate this point. Select the line option, select the line thickness to be equal to 0.13. Draw the vertical trace of the line. So it is 40 mm above the HP. So at the end point of this vertical trace, the front view of the line is of the point is recorded. So let me go for the annotation, select the text, and then mark the front view of the point as C dash because it is above HP and is on VP. So obviously the top view will be recorded on the horizontal plane or just on the XY line. So let me just record the front view here. So it is the point C. So this is indicating that it is in the first quadrant, and if I just enter C here, it is indicating that it is on the second quadrant because the top view is recorded below the XY line if the point is assumed to be in the first quadrant, and it is on the same vertical trace line if the point is assumed to be in the second quadrant. So this is how I can show the multiple views of the same point either in the first quadrant or in the second quadrant. So I can just record the view, that is C is in first or second quadrant. So since the point is on VP, we can assume either it to be in the first or the second quadrant. So go for the smart dimension. Just show the dimension of above the HP. So this is where the front view will be recorded. So just go for the point option, select the thickness to be equal to 2.5 mm and just place the point here and also on the XY line. So with this, we complete the location of the point number 3, that is C. So next point is point D, which is 35 mm below the HP and 30 mm in front of VP. So we can understand that the point is in the fourth quadrant because it is below the horizontal plane and in front of the vertical plane. So we'll take the line option, select the thickness of the line to be 0.13. So the vertical plane is below the XY line here, and that is where the front view will be recorded, and also the horizontal plane when rotated clockwise in the 90 degrees direction, it is going to overlap on the vertical plane and hence it is going to be superimposed on the vertical plane. So with that knowledge, let me draw the front view first, that is 35 mm below the HP. So enter the vertical trace as 35 first. So this is the point where the front view of the point D is recorded, and it is also 30 mm in front of VP. So again on the same line, I'm going to draw 30 mm. So I can just see that I've got two distinct points. So these are the points where the multiple view of the point D is recorded. So let me select the point option, enter the thickness as 2.5. So I'll just place the point here and here. Let me choose the smart dimension. So this is 30 mm, and next this line and this point, this is 35 mm. So let me just annotate the views. So 30 mm is in front of VP, correct? So this will be the point D, which is the top view, and D prime will be the front view. So I can tell that the point D is in fourth quadrant. So let me just record this here. So the point D is in the fourth quadrant. So this is how I have recorded all the views of the point, that is A, B, C and D at any convenient distance over the same reference line or the XY line. So with this, we complete the problem number 1, wherein we have located the points, multiple views of the points A, B, C and D on the same reference line. So now we'll take up the second problem. So the second problem tells that there is a point A which is located 30 mm above the horizontal plane, that is HP, and also 40 mm in front of the vertical plane VP, and we need to draw its projection. So it is very clearly understood that there is an object in the space in such a way that it is above HP and in front of VP. So which tells us that the object is in the first quadrant. So now let us see how to do the orthographic projection of this particular point A. So let us select the line option and first draw the reference line, which is the intersection of the horizontal and the vertical plane. So just draw a line of any arbitrary distance, but ensure the angle is either 0 or 180 degrees. So now let us draw the vertical traces of the point. So now I'll just select the line of thickness 0.13 and draw its front view in the vertical plane. So it tells that it is 30 mm above the ground or the horizontal plane. So it is here 30 mm where I'm going to record the front view. Next is 40 mm in front of the vertical plane. So the top view is recorded exactly below the front view on the same trace. So I'm going to select the annotation text option. So let me just tell that this is the front view of the point A dash and this is the top view of the point A, followed by the XY line to be annotated, and next is the vertical plane and the horizontal plane. And also I can tell that point A is in first quadrant. So let me just go to the smart dimension, show the distance, which is 30 mm above HP and 40 mm in front of VP. So I go for the point, select the thickness of the point to be equal to 2.5 and then place the point at the end points of these projection lines. So you can just see that the point is located. So this is the multiple views of the point A, which is above HP and in front of VP. So with this, we complete the second problem. So now let us go for the problem number 3, which tells that there is a point Q which is lying on the reference line, that is the intersection of HP and VP. So where will its projections be on HP and VP? So let us just take a case and draw the line of thickness 0.18 mm. So I'll call this as the XY line. So go for the annotation, select text and label this as XY. Correct? So since he tells that it is lying on the reference line, so it could be in any of the quadrants, that is either the first, second, third, or the fourth quadrant. So I'll simply tell that I'll go for the line option, select the point option, assign the thickness to be equal to 2.5 mm, and place a point on the XY line. So since there is no data given about the distance, any arbitrary location I can place the point. And now I can just tell that the vertical plane is recording its front view as Q dash and the top view of the point as Q. So if this is the case, then it is in first quadrant, correct? Then again I can go for the point, place the point of thickness 2.5 mm anywhere on the XY line, go for the annotation. So I can tell that Q dash is the front view, followed by the top view, that is Q, right? So this could be either the second quadrant or the fourth quadrant, and I can tell I'll select a point of thickness 2.5 mm, place the point again on the XY line, and if I tell that this is the top view of the point Q followed by the front view of the point as Q dash, I can tell that this is the point located in the third quadrant. So this is how the point could be located. So this is how the projections of the point will be there in any of the quadrants but on the XY line. So next, coming to the problem number 4. So we have a point which is 30 mm in front of VP, 40 mm above the HP, and 50 mm from the RPP. And we need to draw its projections. So RPP here refers to the right profile plane. Okay. So now let us see how to solve this problem. Select the line option. Select the line of thickness 0.18 mm and draw the horizontal line and also the vertical line because we need to have a right profile plane. So now let me just select the line option again, select the thickness of the line to be equal to 0.13 and draw the vertical traces of the point. So this is a point P which is 40 mm above the HP. So its front view is recorded here, that is at a distance of 40 mm from the XY line, followed by its top view, which is at a distance of 30 mm in front of VP. Okay, so this is the condition. So you can just go for the smart dimension, show these dimensions, right? So let me just select the text option. This is the XY line, and this vertical line represents the profile plane. So let me call it as X1 and Y1. So now it is divided. So this is the right profile plane, but he tells that it is 50 mm away from the RPP. So what I can do is I'll use the distance between option, select this vertical trace and the reference line. So it is equal to 52. If I just enter this as 50, you can just see that the X1 Y1 line is shifted towards the left hand side, making the distance between the point and the right profile plane equal to 50 mm. Correct? So now let me just go for drawing the median line. So let me select the point of intersection. So from the point of intersection, I'll be drawing a line of any arbitrary length, but the angle equal to minus 45 degrees. So this is the median line. So the top view is here. I'll draw the horizontal trace of the point, intersect that with the median line, and then draw a line perpendicular to the xy line or parallel to the x1 y1 line, and that line will be drawn till it is intersected by the projection line from the front view, because the side view will always be exactly in front of the front view, correct? So in parallel to the front view. So what I can do is I can just go to the point option now, select the thickness of the point to be equal to 2.5 mm. I'll place the point here and here, that is the front view of the point followed by the top view of the point and the profile view of the point. So let me select the annotation now. So since it is the point P, P dash represents the front view of the point P in small letters, that is P dash, followed by the small letter P indicates the top view, and next is the profile view, that is P double prime or P double dash, correct? So now we can just show the indication of the angle. The distance is also shown 50 mm from the RPP. So we can just enter that this is the RPP. The point is in the first quadrant because it is above HP in front of VP. Therefore, the view that is recorded in the RPP will be the left side view, also abbreviated as LSV. So with this, we complete the problem. However, in order to show the directions of these projection lines, I can use the leader option. So there is something called as leader in the annotation. Click this and select the properties, and you can change the color of the arrowhead to black. Click OK, and then indicate the directions of the projection line. So this helps us understand how the projection lines have been drawn. So we have drawn a line parallel to the XY line from the top view, intersected that with the median line, and then taken the point of intersection. From that line, we have started a line parallel to the X1, Y1 line, and that line is intersected by the projection line taken from the front view. The point of intersection is where the side view of the point is located. So with this, we complete the location of the point P in the first quadrant, which is 40 mm above the HP. So you can just annotate the planes, which is very important. So you can just tell that this is the vertical plane and this is the horizontal plane. So with this, we complete drafting the solution for the problem number 4. Now we will take up the next problem. So there is a small twist in this problem. There are two multiple points. So that is the 2 points R and S are on HP. So it is very clearly told that they are lying on the HP, that is the ground. The point R is 35 mm in front of VP. So we can just tell that it is in front of VP. So which tells that the point R is in the first quadrant or in the fourth quadrant. Anything is fine. Next is the point S. The point S is 50 mm behind VP. So either it is in the second quadrant or in the third quadrant. And the line joining the top views is making an angle of 40 degrees with the XY line, that is the reference line. And we need to find the horizontal distance between the two projectors. So let us see how the solution could be drafted. Let us select the line option, Consider the thickness of the line to be equal to 0.18 mm. So this is the reference line. So we can solve it in two cases. So let us take the case 1 first. Now again select the line option, ensure the thickness is 0.13. So the point is R now, so it is on HP and it is 35 mm in front of VP. So considering that the point is in the first quadrant, I will draw the first quadrant, the first angle projection of the point, correct? So I'll just go for the point symbol, assign the thickness to be equal to 2.5, place that point here and here. So this is the multiple view of the point R in the first quadrant. Let me go for the smart dimension. It is 35 mm above the, it is 35 mm in front of VP. Okay, so 35 mm in front of VP, so it has to be done downwards. So let us just redo this. Use the trim option. So let me just delete this. Take up the line option of thickness 0.13. So from here I'll be drawing 35 mm in front of VP. So select the point option, assign the thickness to be equal to 2.5, place the point here, go for the smart dimension. So it is 35 mm in front of VP, correct? So go for the annotation. So this is the top view of the point. The front view of the point is recorded here as R dash because it is on HP. And then the top view is recorded as R. So assuming that the point is in the first quadrant because it is on HP and in front of VP. So this is the front view, this is the top view. Now he very clearly tells that the line joining the top view of this point R and S is making an angle of 40 degrees with respect to the XY line. So what we need to understand here is there is no particular distance between the projection of R and S, but he tells that it is making an angle of 40 degrees, correct? So first thing I can do is I can select the line option of thickness, say 0.13 mm, and then draw a line in such a way that it is making an angle of 40 degrees with respect to the XY line, correct? So you can just see that this particular angle is equal to 40 degrees. Or if I simply draw one more line parallel, this is 40 degrees. So they are the interior alternate angles, correct? So this is 40 degrees. So now I can just understand that the top view of the point S will be located at this point where it is intersecting the XY line. So I'll select the line option and select the point from this. Thickness of the point is say 2.5. The point of intersection, I'll place the point, and this is the top view of the point S, so which is small s like this, right? So top view of the point R is this and top view of the point S is this, correct? And then the S is 50 mm behind VP, correct? So it is behind VP means what? Second quadrant. So let me select the line option of thickness, say 0.13. So from this point I'm going to draw a line of length 35 mm which is behind the VP, and select the point option and enter the thickness of the point to be equal to 2.5 mm. Place the point here. So let us just use the small letters for annotation. Select the text option. So this is the top view of the point which is small s, and this is the front view of the point which is S dash, correct? So this is the location of the point in the second quadrant. So now with this condition, use the distance between this and show the distance which is equal to 41.71 mm. So this is the distance between the 2 points, that is the projectors of the 2 points. So use the annotation again. So annotate the reference line as X and Y. So for the point R, this was VP and this is HP. But for the point S, this is VP on which the horizontal plane is superimposed, so shown inside the bracket. So this is the distance between the end projectors or the projectors of the point R and S, which is equal to 41.71 mm. So the same point problem can also be solved by considering the point R to be in the third quadrant. So what happens is the R dash is going to be here, R is going to come here, and then you can just show the distance between the top views of the points. So R is here and S is here. So again, the distance will be the same. It will just be the mirror of this. Okay, so the point S is going to be in the fourth quadrant because it is in front of VP. It is behind VP. So the point S is going to be in the third quadrant and the point R is going to be in the fourth quadrant. So this is how you can draft the solution for the fifth question.